Hi everyone, today I'll be doing number 23. A fireworks rocket explodes at height h, the peak of its vertical trajectory. It throws out burning fragments in all directions, but all at the same speed v. Pellets of solidified metal fall to the ground without air resistance. Find the smallest angle that the final velocity of an impacting fragment makes with the horizontal. Alright, so I guess I can start by drawing out a diagram for this. We're told that a rocket explodes at height h. So let's draw the explosion here. This is the explosion. All right, yeah. This is the ground. We got fragments going off there, and then we're going to draw a reference fragment going this way with velocity v as always, and forming an angle that's called theta with the ground. So we know that the velocity is v, and we know how to find theta, being taking the inverse tangent of the x and y components. So let's start by finding the components. We know that the Vx component is equal to V cosine theta because there are no external forces acting in the horizontal direction. And then to find the y, it's kind of more complicated because it has gravity. So what we can do is use the kinematic Vf squared and Vi, which in this case is V sine theta squared, plus 2 gravity h. So we can simplify this a little more. The v in the y direction would be the square root of v squared sine squared theta plus 2gh. So now that we got the horizontal and the vertical components, we can take the inverse tangent of the y component and the x component. However, because it's asking for us to minimize right here, we would take the limit as theta approaches 0, correct? So we got the limit as theta approaches 0 of the inverse tangent of the y component and the x component. So then we can plug things in, theta approaching 0, tan inverse of the square root of v squared sine squared theta plus 2gh over v cosine theta. Alright, and then we know that as sine theta approaches 0, approaches 0, sine theta also approaches 0, so the entire term cancels out to 0, and cosine theta as theta approaches 0 is equal to 1. So then all that we're left with is theta is equal to the inverse tangent of the square root of 2gh over v. That is our minimized theta.